Good afternoon, everybody. Today I'm gonna be solving Codeforces Round 725 Division 3. The main goal is not to be on the top, but to explain all my thought process. So I'll be telling out loud all the thoughts that come to my mind, and you can compare it with what you would think if you were solving these problems. And at the same time, it's not like an editorial, so I won't be explaining the whole solutions. I'm just gonna say things that come to my mind when I see these problems, when I solve them, and etc. So I hope it will be helpful for you. You can write down in the comments what do you think about it. I have everything set up. I have my Mac Vim where I'm gonna be writing my code. I have a whiteboard where I'll be drawing when I need to. And I have my Codeforces. So let's see how many problems do we have. It seems like we have 7 problems and 2 hours to solve them. I want to believe that we will be able to solve them faster than 2 hours, but we'll see. Okay, that's fine. Let's have it like this and just swap these 2 pages. So the contest starts. Let's go. First of all, we should open all the problems. Okay. And stones in a row. The stone position to power AI. First position. Last position. Okay, I got it. So he should destroy the smallest and the biggest number and make as little number of moves as he can. So it's pretty straightforward. Let's take all the values. I is A and J is max element. So, and the answer is maximum of I and J and n minus minimum of I and J plus 1 and minimum of I and J plus n minus maximum of I and J and plus 1. Yeah, okay. So 2, 4, 5, 3, 2. Element, oh, okay. 2, 4, 5, 3, 2. Okay, let's submit it. And go to the next one. And friends, wait, it's more than 2 hours. Okay, whatever. Don't like when they have different number of candies. Chooses K. Distributor. What? What? Oh, I got it. Okay. Okay, that's also super straightforward. We should just take all the people that don't have the amount of candies equal to the average. So we have vector, right? A. If %n isn't equal to 0, then it's impossible. It's impossible. Otherwise, sum divided by n, val isn't equal to cnt, ans plus plus. We're printing the answer. 2, 1, minus 1, 0, 0. 3, 2, minus 1. What? Oh, I was wrong. Oh, that's not what they wanted us to have. We should take all the numbers that are bigger than CNT. 2, 1, yeah. Okay, I'm sorry for that, but I found that fast. Okay. And of n integers, I thought in the previous problem that we take k people and distribute among them, but it's the other way around. Sum is greater than or equal to L. Okay, in the consists of 3 integers. Find the number of pairs such that the sum is in the range. I don't want to use fanfic tree though. Oh, yeah, NLR. Sum, prefix sums, difference of prefix sums. They are positive. That makes a lot of sense. Yeah, if they are positive, we can just binary search it. Or we can use 2 pointers. Yeah, I thought they can be negative, but that's fine. Okay, we have LR. So don't want to care about any overflows. Okay. So yeah, we go left bound is 0. No. Left bound is 0, right bound is -1, I guess. That's a little bit confusing. No, let's do binary search. It's gonna be easier because we have binary search built in. Left bound is lower bound for pref begin, pref end, and the minimum number such that their difference at least no more than r, so OB is at least I minus r. Pref begin. Right bound is lower bound for upper bound, I guess. At least L. More than minus R, right? Wait, what? Minus L. If RB, okay, RB is minimum of RB and no. Here is 0, at this point is 0. Yeah, so it seems like it's just if OB is less than RB, minus plus equal RB minus OB, something like that. I don't know, kind of confusing. 2701 504. 51243 0 5 6 8 12 15. 25027, right? 11 212 312 412 111. Yeah. So it's 0. But 5 is okay. 5 is definitely fine. Wait. Minus 5 and minus 0. This is 0 too. But we find upper bound for 0. Why is it 0? Wait. What? Why is it 111? Upper bound of 0 can be 0. Prefix I plus 1. 2605 is also not true. Oops. One, 2. Should be 2 here. It's 8. Lower bound for 0. Upper bound for 3. One, yeah. 2, 4. Yeah, and here have 7. Wait, what? 1, 2, 3, 4, 5, 6. Why isn't it 6 though? 1, 2, 3, 4, 6. Oh, 7. Yeah. What? Wait. 1, 2, 3, 4, 5, 6. I'm missing something. Wait. Oh my god. It's not the prefix sums. It's the sum of the elements. What? Wait, no. What? I misread the problem. Let's say pref equal. Oh yeah, let's not say that. That was really bad. Oh no, oh no, 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 no. No, wait. Yeah, I should take R minus this. L minus this. Plus 1. RB is minimum of RB and I. OB is minimum. 2701. Oh god. That was brutal. That was brutal. I misread the second problem in a row. You're given 2 integers. In one turn you can do one of the following operations. Divide the numbers to make equal. Exactly k turns. Oh. Okay, yeah. Makes sense. So it's kind of always possible except some cases. Yeah, for example, if k is equal to 1, a should be divisible by b, or b should be divisible by a. If k is more than primes of a plus primes of b, it's impossible. And what else can it be? Divide. You have this number should divide them a couple of times, so they, yeah, should be possible. Yeah, so in all other cases we can do them once, both. Okay, so we take ABK, and if k is equal to 1, A% B is equal to 0, or B% A is equal to 0. Oh, they can be equal. If A equal B, then it's impossible. Yes, and otherwise we print no. Return 0. Okay, if k is more than get primes A plus get primes B, no, and otherwise we print yes. Get primes. While A% I is equal to 0, I divide equal I, ans plus plus, if A more than 1, ans plus plus. Is it fast enough though? I guess it is. Yes, 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 no, yes, no. Okay. Let's make it all integers so that it works faster. Yeah. Okay. Let's submit it. Okay. Yeah, I was really bad with problem C, where I struggled because I misread the problem. Assign the variable x. Okay. One space h, yeah. Okay. Okay, that's kind of weird. Okay, the problem is that the strings can grow exponentially. So we should store the last, like, 3 letters, the first 3 letters, and the number of occurrences for each variable. Yeah, seems like that. Not really a great way to solve it, but I don't see any other. So let's make a structure variable that consists of answer, beginning, ending, and what can we do? From an empty string, answer is 0, is empty string, empty string. From a string, we say that we'll find answer. We'll do it. Find answer. Beginning is S. Okay, let's S if beginning is more than 3, then resize of 3. Reverse engine equal S if its size is more than 3. Resize, reverse, okay, and also we should have combine. Let's make it get back and back engine. Yeah, and here we say that get back and back is equal first, engine is equal to second, and in combine we take C beginning is get back and A beginning plus B beginning dot first, and ending is second for ending and ending. Okay. Now we should find out the answer. It's A answer plus B answer plus find answer for A ending plus B beginning. Seems like that. And here we just go through the string. I plus 4 no more than size. if the j isn't equal si plus j, false, break. If okay, answer plus plus, return answer. Okay, now what do we have? We should also have like map from string to variable. So we get var name operator, var name operator. If operator is equal to sign, then we take a string and q var name is equal to variable of s. Otherwise, we take left operator 2 and right, and q var name is equal to combine ql qr. Let's say new value. Q var name is new value. So, and last statement. Answer is equal to var name dot answer. Yup, things like that. So let me try it out. Seems to be working though. Okay, let's submit it. Okay, let's go to the next one. Two integers, add 1 to L until the result is equal to R. For such addition, let's look at the number of digits that will be changed after that. Okay. Yeah, 2 digits, 5 digits, 10 digits if you want to get. So we go from 1 to 9. Yeah, makes sense. Okay, so the first thing that comes to my mind is that we should go from another side. We should for each digit find the number of times it changes. And it seems to be a pretty straightforward thing. We should kind of divide these numbers and take their difference. Yeah, isn't it just that? I think it is, probably. So we take N, take L and R. Answer. But wait, no, it's not that easy. Maybe it is. While L plus R is more than 0, while R is more than 0, ans plus equal R minus L, R divided by 10, L divided by 10. Wasn't the previous problem much harder? Why these even problems are so easy? And C and A are much harder. Has X of red and Y of blue candies. Using them, he wants to make gift sets. Each gift set contains either A red candies and B blue candies. Wait, what? Then we want to make gift sets. And candies can belong to at most one number of gift sets he can create. For example, there is one red candy that Polycarp does not use in the gift set. X, Y, A, B. Okay. Makes sense. So, we have X and Y, and we can take AB or BA, and we want to find the maximum amount. First thing is to binary search the answer. The answer is A, and if we take K of these and A minus K of these, then it's KA plus A minus KB is no more than X. BK plus A minus KA is no more than Y. So let's write it down as this. K divided by A minus B isn't bigger than X minus AB. K multiplied by B minus A isn't bigger than Y minus AA. And if this can be done, then the answer is yes. And we should be careful about if this is positive or negative. Right. Yeah, kind of makes sense. Okay. So G 1, 2, 3, 4, 5. Okay. XYAB, XYAB. So maximum number is our 0, or is probably, I don't know, X plus 1 or something. And while R minus L is more than 1, we take M, which is equal to plus R divided by 2. We print L. Left bound is minus infinity. Our bound is infinity. If right bound is at least left bound, then L is equal to M, otherwise R is equal to M. So let's take the first thing. Up is X minus M multiplied by B. Down is A minus B. If down is at least 0, or if it's equal, if they are equal, let's say if A is equal to B, then minimum of X and Y divided by A. A minus B, if more than 0, then let's just say that if A is less than B, we just swap them. So we definitely know that it's upper bound, so right bound is up divided by down, but we should take it modular, right? Up minus up percent down plus down percent down divided by down. Up 2 is m multiplied by a minus y. Down 2 is b minus a. And here it's lower bound. Up 2 should take more than that, right? Minus, okay, let's take this and if up 2% down 2 isn't equal to 0, left bound plus plus, something like that, I don't know. Well, if they are negative, I guess it doesn't matter, so we can do it easier, yeah. If up is less than 0, RB is 0, otherwise RB is just this. If up 2 is less than 0, left bound is wait, what? It's a right bound. Less than 0, then it's minus 1. Yes, and it's a lower bound. Okay, so it's 0, and otherwise it's up 1 plus down 1 minus 1 divided by down 1. Yeah. Up 2. Ten 42. That's too much. That's too much. 10 12 to 5. 10 12 to 5. We swap them, so it's 5 2. This is 3. This is like 10 minus something multiplied by 2. This is minus 3. Twelve minus something multiplied by 5. Let's see what happens. Minus 3. Wait, what? No. A minus B. 3. Yes, okay. 304 11115. Oh. Should be O, but it's 1 for whatever reason. 4 1 2 3 4 1 3 2. Y minus no. minus k divided by b. Right bound. Minimum of right bound. No. Wait. Left bound. Okay, let's just check. That's left bound multiplied by a plus no, wait. And left bound is no more than m, something like that. Yeah. 304 11151. Okay, that was not really ideal, but we did it. Okay. 10th place. Yeah. We could do it much faster. First of all, it was a disaster with problem C. Second of all, I was not that fast with problem G. I probably could solve it a little bit faster. But yeah, problem F is just hilarious. Like, someone took 1 minute to solve it. That's a really weird problem. What can I say? Yeah, what is that? Yeah, what else can I say about the problems? Let's see. So the first one, the first one is kind of interesting. We should take some prefix and some suffix so that two elements in between are taken. So there are pretty much 3 cases. So we should consider either we take each element from the prefix or from the suffix. So we either take both from the prefix, then it's maxima plus 1. Both from the suffix, it's the same, but we take n minus minima, and otherwise we take minimum from the prefix and maximum from the suffix. It's this plus this, so it's just a formula. And it's always nice to use built-in functions to not write your own cycles or something. Okay, problem B was a little bit, I kind of misread like half of problems, I think, and this is one of them. I thought that we should take k members and then distribute their stones between them, but it wasn't right. We should take some members and distribute among all the others. So basically we should take like the average. We know that the sum divided by n should be the number of stones that everybody has at the end. And if it's not divisible, of course, the answer is -1. Otherwise, the answer is yes. And we should just take all the numbers that are bigger than this number, because of course we should take some stones from them. And it doesn't make any sense to take some stones from the members that have less than we need. Okay, so the problem C. I don't know why I'm talking about that. It's like not a tutorial. I'm just trying to explain at the end again what I thought about these problems when I was solving them, and maybe giving some more clues about what I was doing, because maybe I was not that it wasn't that clear what I was saying when I was in the process of solving. So yeah, here I also, I don't know, first when I read the first sentence, I understood that we should take the sum of two elements. But when I was here, I for some reason thought that we should find the number of, the number of like segments. I think it was because I saw this L and R are about segments, so I thought, okay, we should find out the number of segments, which sum is in this interval from L to R, but it was not true. But as in the problem, what it was, B, it was not that hard to rebuild my solution. The only difference is that in my version of problem, we should just take prefix sums and then solve the problems how much there are pairs, so that prefix sums j minus prefix sum I is equal to this number. But here we should just sort the array and then either go with 2 pointers, which I thought that is not the best option because it's really easy to do something wrong. And with binary search, we have built-in binary search, so it should be much better. And here we just binary search for the first number that is okay for us and the last one. And then in this case, they can be bigger than our number. And in that case, we would find this ij pair twice. So it's bad. So I take minimum of this and I. And this if is useless, because if it's not less, then it's 0, because it's of course can't be less than this. Problem D, what I was thinking about that. Yeah, it's a really weird problem. So it's always, kind of always good to make both numbers a and b equal to 1. And the only question is how many operations can it be? There is only one corner case when k is equal to 1. Then we can't apply operations to both the numbers, and then we should just take one number and divide it to get the same as the other one. And also there is a corner case inside a corner case, because if a is equal to b, it's impossible. Otherwise, they are divisible, it's okay. Otherwise, it's not okay. And if we forget about this corner case, it's just about we have k that is at least 2, and we should just divide these two numbers as many times as we want, so that the sum of these two numbers of divisions is k. And there isn't much of a complex stuff. It's just about we can only divide by a prime number every time. So if there are less than k prime numbers in a and b together, then it's just impossible. So I just found the number of primes. The only thing I was not sure is that my solution works in like square root of 10 to the power of 9, and there are two 10 to the power of 4 test cases, and that's not great. And as we can see, it takes like 3/2 of the time limit. But I guess, like, if we don't use this, what should we do? Should we like, maybe we could, maybe it would be better to first make a sieve, find all the primes, and then go here through all the primes that are not bigger than square root, but not all the numbers. But I mean, it's too hard for problem D. So the problem E was a little bit tricky. It was about, I don't know, writing some code, not really about thinking. So we should just implement what we were asked to do, but the only thing is that we can do something like this, which is shown here. The size of the string can be multiplied by 2 every time, and if we perform 50 operations, it's like 2 to the power of 50, which I guess is 10 to the power of 15, like really big number. We can't store this long string. So the thing is, we store for each variable the answer, so the number of substrings, haha. And at the same time, when we combine two strings, we need to find the number of haha in their intersection. But we don't need to store the whole string. We just care about the characters that can be in this intersection, and it's just the first three characters and the last three characters. And I thought that the best way to implement it is to make a structure that stores the answer, the beginning, the ending, and then re-evaluates these numbers. Okay, the problem F was super easy. So as I said, the first thing that comes to mind is that we should take like a different perspective for this process. We should not find the number of the sum of numbers of digits that change every time, but for each digit find the number of operations in which this digit is changed. And each digit changes every time when we have like number like x9999, then we add 1, and then it's x plus 1, 0, 0, 0. So then this digit x changed. And for example, if we have the last digit, it's obvious, then it changes every time. So it's just the difference of left bound and right bound. And if not the last digit, then we should just delete these last digits after it and take the difference. So the code is like 5 lines. We just take each digit, divide it, and then take the difference, and so on. And the problem G was also not that hard. I messed up the formula. That was my bad. So we just do a binary sort for the answer. Let's say that we take k, the answer is A, and we take k, what was the word here? Gifts. Gift sets of this type and A minus k of this type. Then we just write the equations that this shouldn't be bigger than x, this shouldn't be bigger than y. Then we take k to one side, everything else to the other side. And I think I should have multiplied it by -1 so that it would be easier to see what's the actual formula, but I didn't do it. Whatever. And the last problem was that, okay, we found out the interval in which we should find the answer, but even if RB is more than LB, we should also check that LB is less than M, because there can be a solution for this in which we take we have A is equal to 5, and we try to take 6 of this and -1 of this, and it's of course not correct. So here we check if it's negative, but we didn't check if this number is negative. So we need this LB is not bigger than M. Or we could even not care about RB. We know that if the answer exists, there is this segment from LB to RB. And then we know that if the answer exists, LB is the answer, of course. So we could just find LB and then check that LB is okay with these inequations and LB is not bigger than A. So that's it for today. We solved all the problems. We are on the... Oh, some people are getting ahead of us, but we'll see at the end what's our place. But I want to believe that we will be able to be in top 20. That's fine. We could do much better, but anyway, thanks for watching. I hope that it was helpful. About educational content, I'm a little bit busy right now. I have my university exams and all this stuff, but they will be sooner or later, sometimes in the future. So thanks for watching. Have a nice day. Bye.